Hello and welcome to this first Getting Started tutorial for Numerus. Numerus is a multi-purpose modeling program that allows you to design and then run a broad range of models, from very simple models like population models to some pretty complicated models such as spatial models or agent-based models. In this introductory tutorial, we'll go through the parts of the Numerus interface, introduce some of the language we use to describe models both generally and specifically in Numerus, and show one of the sample models that come with Numerus. Then in the next tutorial, we'll build from scratch a simple population model. So let's begin by looking at the Numerus program. Numerus uses two frames, one for model design and the second for model execution. We are currently looking at the Numerus design frame. Now you can see that this frame has several sections or panes separated by sliding dividers. So you can always enlarge the section you're working in. The big pane in the center is called the modeling canvas, where we design our model using the graphical modeling environment, which is a little bit like designing a flow chart or an organizational chart, in that we add objects to the canvas and then connect them together. All of the objects, components, displays, controls, plugins, code chips, are selected from one of the design tabs found on the left-hand side of the frame. These tabs also include additional tools for enhancing the functionality of your model. On the right-hand side of the frame, we find the property pane. This is important for specifying specific properties of the components, displays, and controls that your model requires. In the upper left corner, we find the simulation parameter panel. Here's where you determine the runtime properties of your program. Now, this is a good time to point out the difference between a model and a simulation. A model is a description of a system and how it changes. The model directs the execution of a simulation, which then produces useful results. So now let us load a model from the model library included with Numerus. Numerus comes with a model library that contains a number of models in various paradigms. The model we select is a well-known example from System Dynamics, in which we have a population which varies dynamically at a rate proportional to its current value. This results in what is called exponential growth and decay. This model requires 6 components. The central component, labeled pop, is a stock whose value is the current population. If we click on the stock, we see its property pane, which contains its name, type, and initial value. The initial value refers to a term called initial pop, and if we click on that component, we see its property pane. We've chosen to set its value to a constant 1. Next, we visit the flow labeled burst to see its property pane, and we see it has a value that depends on the current population, that is a pop, and a value called birth rate, which is derived from a slider. If we next visit the properties of the flow labeled deaths, we see it is similarly dependent on pop and on a different slider. Visiting the properties of the sliders, we see that we can set a range of possible values and fix the initial value and the step size. Finally, we wish to display the values as the simulation runs, so we include a graph display and indicate that the value to be displayed is pop. Before running the simulation, we need to consider the four simulation parameters that determine the behavior of the model when it runs. Start and end time are fairly self-explanatory, except that they represent an abstract concept called model time, which may be any time unit you choose, and you can specify that time unit. dt is the interval between steps in the simulation, and so the simulation proceeds from start time to end time in steps of length dt. Finally, the method refers to the process by which the change of stock values is computed, and this will be discussed in greater detail in the next tutorial. We've chosen RK4, or Runge-Kutta 4, which is appropriate for this type of model. Okay, now clicking the Launch button opens the runtime frame. This frame contains a large region in the center called the dashboard. The dashboard is composed of a section at the top of controls and a larger section at the bottom of displays. The controls and displays correspond to the slider and graph components we saw on the model canvas. At the top of the frame in the toolbar, we have controls and displays for the simulation. On the left is a panel of buttons to run and stop the simulation, continue from the stopping point, and to reset at the beginning. There are also buttons to single-step the execution and reload the model. On the right-hand side of the toolbar, we have a display showing the start and end time and model time for the simulation and step size dt, and the integration method. Note that you can change these values temporarily before a run. Another text field shows the current time while the simulation is executing, and a slider is available to control the speed of execution. Finally, there is a text field showing how many runs have occurred since the program was loaded. We now run the model by clicking the Run button, and the graph appears almost immediately. If we run the cursor over the graph, we can view the value at particular points in time. And we can also change the graph into a table and review all of the results. If we want to run the simulation with different parameters, we can use the slider to set new values and then rerun the simulation. We can also interact with the simulation using a console window, which lets us query the values of the variables at any point in time. Using the single step feature, we can incrementally step the simulation and check on variable values along the way. This is particularly useful during model construction. Notice the tabs at the bottom of this window. These are analytical tools that are important to more advanced model construction. We will see these used in later tutorials. This concludes our introductory visit to the Numerus Model Builder. We've learned that Numerus is a multi-purpose software in which models are designed visually. Please visit the model library to become acquainted with the range of possibilities available with Numerus. In the next tutorial, I will show you how to build and run a simple model. See you soon.